Next, let's take a look at the structural modeling area. So one thing you'll notice is there's a build from CFA option. If you do this, it will automatically take all of the latent factors implied by this model and stick them into your structural model, including higher order factors. So I'm going to get rid of this higher order factor and this higher order factor. Let's keep this one just so you can see what happens. I'll probably get rid of it later though. So I'll click Build from CFA. Here it is. You can see here's JobSat, the higher order factor. I'll put this over here and put these two over here as its dimensions, even though I don't know that that's a valid higher order factor. And then I can just drag things around. Now, if you didn't build from the CFA, you can just drag in from over here. So just as with other panels, you can just click any variable and it finds the prefixes that are similar and selects all of them. If you don't want all of them, you can always right-click one of them or right-click and drag, and it deselects them. If you left-click and drag, though, it thinks you want to put it out here as a single composite or observed variable, like this. That is legal. You're welcome to do that, and it will work, but typically we'd only do that with variables that are not part of latent factors, or if we already have factor scores. But if I pull out an entire prefix group, just drag that out, it creates a latent factor with 3 indicators here. Let's take this back out. All right, so what we have here is a canvas where you can just drag things around, snap them to, and let me just put these in an order that maybe makes some sense. Let's see, if I get feedback, I'm more likely to participate, which may lead to higher job satisfaction, something like that. And this is learning orientation, which means I learn from my challenges rather than feeling like I'm burdened. To correlate variables, you can just hover over a variable. If you're on the left side, a correlation arrow comes out. If you're on the right side, a directional regression arrow comes out. And you can see it snaps to something you can connect with, and then connects them. If it is endogenous, it automatically gets a residual, which you can drag around if you like. And you can also covary this residual if necessary. There are good reasons for that. We're not going to do that right now. If you forget to covary, then when you go to run this, it will warn you and ask if you want to covary everything and do it for you. Let's see that in action. I will leave these uncovaried for now. Also, you may have noticed the covariance always bulges to the left, no matter whether I drag it from the top or from the bottom. And even in here, you can create higher order constructs. I'm just going to right-click this for now to delete it. Also, Control-Z and Command-Z works in here just fine. I just did Control-Z and it came back. Delete that again. Let's connect these, and let's connect this. We now have an implied indirect effect right here. And we can even throw in an interaction. To interact, you just, again, grab a regression arrow and drag it to another arrow, like that. That is an implied interaction. I can also add these direct effects right here and move things around to make it look a little bit better. If you want to see the measurement model, you can always click on this measurement button, and it will show you which variables are part of which latent factors, and then hide it again. While in here, you are welcome to delete variables. That does work. This maximizes the fit, so it fits the view. If you scrolled out, for example, click that, and it'll jump back to full view. This will delete the entire model, clear the canvas, and this will copy the model out to a clipboard. So I've just copied it. Let me go paste this in a Word document. There we go. Paste just fine. Now, the options we have up here are Build from CFA, which we already saw. To run the SEM, click that button. This is just an estimate of how long it might take. It says you have 304 sample size with 24 nodes, 6 paths, 0 covariances currently, 17 measures, 48 parameters, roughly, and we're going to run MLR, and we're not going to bootstrap, and there is an interaction. So it'll take about 44 seconds, is what it thinks. It's not a perfect estimate, but it's relatively close. Notice if I do something like bootstrap, it jumps up to a lot longer. Bootstrapping takes a while. Bootstrapping is defaulted to off. Notice I also have LVS equal to true here, which is this button. Latent variable scores are just a Bartlett score. And this is defaulted to on, so you're running a 2-stage approach. This is especially recommended when you have an interaction, so that you're not doing a whole permutation on every pair of indicators across your independent and moderating variables. That can get pretty complex. You can uncheck this to run a latent model. That's fine. It just takes a lot longer. The default estimator is MLR, but there is the option for WLSMV, which may be recommended if you have categorical or binary variables. You can change your confidence level, of course, and you can choose to filter by group or even compare by group to do a multi-group analysis. I'm going to take that off for now. And you can reduce the sample size by randomly sampling in here. And that updates. So that is an overview of the setup area for structural modeling. Let me just run this real quick to show you very briefly what is produced, but I'll leave a deep dive for other videos. Notice when I clicked Run SEM, it says, wait up, you have exogenous variables that are not covaried. Would you like to covary them now? If you say apply covariances, it will automatically do this. If you do not, it will leave them uncovaried. I'll go ahead and apply that. Notice it did throw that on there. And it's going to run through the analysis. Since we're using latent variable scores, it didn't take very long. And it comes up with what you did, what we found, how to interpret things, path estimates, correlations, indirect effects, simple slopes, Johnson-Niemann plots, model fit, post-hoc power analysis, and the R syntax. And you can copy everything from this output to the clipboard. Well, that's an overview of the structural modeling. I'll dive a little deeper into each of these topics in a subsequent video.